We're going to use the rational zeros theorem to make a list of the possible rational zeros of the function. In other words, we're going to find where the function's graph crosses the x-axis. We are going to find possible factors by looking at the constant and putting its factors in the numerator, then putting factors of the constant in front of the highest order variable in the denominator. So our possible factors are plus or minus 1/2, plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Next, we're going to set our function to 0 and use one of our possible zeros to perform synthetic division to factor the polynomial. You can use your graphing calculator to narrow down which zero to try first. We're going to start with the function value of 4. So let's test the function value of 4. 2 times 4 to the 4th minus 7 times 4 to the 3rd minus 8 times 4 squared plus 14 times 4 plus 8 equals 0. Since function value of 4 equals 0, x minus 4 is a factor. So we'll use x minus 4 as a divisor of the polynomial by using synthetic division. You can see we've set up the first row here. Bringing down the 2, we multiply 2 times 4 and we get 8. Positive 8 and negative 7 gives us 1. 1 times 4 gives us 4. 4 and negative 8 gives us negative 4. Negative 4 times 4 gives us negative 16. Negative 16 and 14 gives us negative 2. Negative 2 times 4 gives us negative 8, which combined with positive 8 gives us a result of 0. Since the remainder is 0, x minus 4 is a factor, and you've found another factor, 2x to the 3rd plus x squared minus 4x minus 2 through synthetic division. Now we need to use one of the other possible zeros to factor further. These are the possible rational zeros we found at the beginning of the problem. Looking at the graph again, we're going to test the negative 1/2 value. So this time we'll use x minus a negative 1/2 as a divisor of the polynomial using synthetic division, which you can see here. So now we have a much more factored form of our original polynomial, but we can still factor further. So here you can see we're simplifying the sign, right? X minus a negative 1/2 becomes x plus 1/2. We can factor out the greatest common factor of 2 here, and then factor out the difference of 2 perfect squares to fully factor here. Since this is set to 0, we can discard the constant of 2. We would then solve each of the factors for 0, and we get the rational zeros of 4 and negative 1/2, and the irrational zeros of the square root of 2 and negative square root of 2. To recap the process, first use the rational zeros theorem to locate possible zeros. Use your calculator to narrow down possible zeros. Use the synthetic division to rewrite the function as a divisor and quotient. Repeat synthetic division of quotient until you can factor the remaining quotient. Use the zero product property to find all real zeros.